Welcome everyone, this is Dr. Mercola, and you all are aware that cancer is a profoundly important problem that challenges most all of us at some point, or certainly someone we know. And we're really privileged today to speak with Dr. Dominic D'Agostino, who is an assistant professor at the University of South Florida College of Medicine, and he teaches courses in molecular pharmacology, physiology, and maintains involvement in several studies researching metabolic treatments for the neurological disorders such as seizures, Alzheimer's, ALS, and cancer. So they're all really related, and it's interesting that that there's a central component that is really relevant for so many of these widely diverse diseases. So welcome, and thank you for joining us today.
Thank you. I'm glad to be here.
Yeah, we're really excited because you've got you're really on the cutting edge research. I'm wondering if you could explain to our viewers how you first became interested in this area, because it's so fascinating, and I really look at you as one of the primary leaders in establishing some of the basic foundational precepts that we have to treat so many of these wide diseases, especially cancer.
Okay, thank you. My entry into this field of cancer research was pretty unexpected, actually. I was funded to study the effects of gases on the brain. Specifically, the funding was from the Office of Navy Research in 2007 to study seizures related to oxygen toxicity that are experienced by Navy SEAL divers using a closed-circuit rebreathing apparatus. And as I delved into neuroprotective strategies to prevent oxygen-related seizures, I came across the ketogenic diet. And I found it interesting that the ketogenic diet is very effective for drug-refractory epilepsy and a variety of seizure disorders. And in studying this, more intensely, I wanted to develop a ketogenic diet strategy for the warfighter to protect them from the effects of hyperbaric oxygen. And I realized that, your brain primarily runs off glucose for energy. And during periods of carbohydrate restriction or calorie restriction, it can derive fuel from ketone bodies. So I delved into the nutritional physiology, I guess you could say, of ketone body metabolism. And we further pursued ketosis as a strategy for oxygen toxicity and developed ketone supplements, which have been shown to be very effective. And in addition to that, the research indicated that ketosis could be a therapeutic strategy for cancer. And I came across the work of Thomas Seyfried, and I came across a large amount of evidence that suggested that cancer was unique in that it was metabolically unique. Genetically, it was very heterogeneous. So there are a host of different genetic anomalies in cancer cells, but one characteristic is that it had this ubiquitous metabolic phenotype, which was aerobic glycolysis. So even in the presence of oxygen, it was shown that cancer cells continue to pump out lactate, suggesting that they're fueling their metabolism from excess glucose consumption. And, from my perspective, the only reason, cancer cells would be pumping out lactate and deriving energy from glucose at such a high rate would be because they are metabolically compromised with mitochondrial deficiency. So insufficient oxidative phosphorylation, which takes place in the mitochondria, contributes to a compensatory fermentation. So the cells are forced to get energy from somewhere, and the mitochondria are not functioning, so this destabilizes the nuclear genome and activates the oncogenes, which then kind of increase the glycolytic enzymes and the ability enhances the ability of the cancer cells to derive energy from glycolysis. So, in studying nutritional ketosis for an application related to seizures in Navy SEAL divers, I came across a body of evidence to suggest that not only was therapeutic ketosis neuroprotective, and it functioned, ketone bodies function as an alternative fuel to enhance brain metabolism, decrease reactive oxygen species, and also they have a brain stabilizing effect, which we can exploit with the ketogenic diet, which we call nutritional ketosis or ketone supplements. But that there's a body of evidence suggesting that cancer itself would be responsive to therapeutic ketosis, because nutritional ketosis involves carbohydrate restriction. So that would decrease glucose availability to cancer cells, and it would increase the production of ketone bodies from the liver. And your normal cells have the metabolic flexibility to readily adapt to using ketone bodies for fuel. And cancer cells lack this metabolic flexibility to do that. They can't derive significant energy from ketone bodies, the large majority of cancer cells. So in testing our nutritional strategies or ketone strategies for seizures, we looked at a few cancer cell lines and saw a robust effect probably about 4 years ago. And so it all started about 4 years ago as just a simple observation in a glioblastoma cell line. And that led to the work we're doing now.
So you're really on the beginning stages of this, because 4 years isn't really a long time as research goes. So
yeah, I'm brand new into this, and even a junior faculty member, and but it's such an exciting field to be in because there's really not a lot of people doing it.
Yes.
And the reasons for that are interesting, I guess you could say. There's not a whole lot of money, and there's really not a whole lot of people understand nutritional biochemistry, but nutritional physiology is not really appreciated.
Yes.
Kind of how our nutritional strategy influences the body as a whole, not just at the level of the biochemical level, but as a whole.
And that's one of the reasons why I'm so excited about connecting with you and dialoguing and understanding what you're doing, because you're really one of the upcoming researchers that's going to, you've got your whole career in front of you, and you're really passionate about this, and you're really going to uncover so many foundational key solutions to these challenges, these health challenges that so many of us or our relatives face. What I'd like to do is deconstruct some of the very eloquent language that you use to explain what you're doing, and sort of simplify it for a large number of our viewers who aren't as educated in nutritional biochemistry. So if I can summarize this, and correct me if I'm wrong, most of our cells in our body, our own cells, have the metabolic flexibility to use either fat or sugar, which is basically the two fuels that we can do. Except for cancer cells, there's some aberration that really allows them not to use this fat or the ketones as a fuel, and they really can only use glucose. So it's sort of a derivative of what Dr. Otto Warburg discovered and actually received a Nobel Prize for in the 1930s, that he learned that glucose or sugar is really the primary fuel substrate for cancer cells. But yet oncologists have ignored this for over 80 years and don't use it therapeutically, which is just reprehensible, almost criminal, because so many people suffer needlessly because they don't have access to this simple nutritional therapeutic strategy. But essentially that's it. Is that to take advantage of this metabolic differential that cancer cells just don't function on fat, so that if you can shift over. And here's, I guess, where the confusion is, at least my understanding, and please correct me if I'm wrong because you're the expert here, that most of us have, we have limited stores of sugar. We only store it as in the form of glycogen, typically in our muscles or our liver. But that storage is relatively short, typically 12 hours or so, maybe in some people go to 2 or 3 days, but it's relatively short, whereas fat we can go on for months almost, many of us. So, and it's this conversion, so that, because if we eat carbohydrates all the time, we continually replete that glycogen store, so we never get down to, there's always sugar available for cancer cells. So it's a matter of depleting those glycogen stores and going to ketosis. So maybe if you can expand on what I just attempted to simplify what you mentioned. So,
yeah, that's a good point, and you bring up a lot of a few interesting questions here. In theory, it's pretty simple, right? You eliminate carbohydrates, you decrease the glucose availability, and you should, in theory, starve cancer cells of their
Right.
primary source of energy, glucose. The thing is that our physiology is a little more complicated than that, and when we, restrict carbohydrates, we may prevent the spikes in blood glucose and the spikes in blood insulin, these spikes are actually very pro-inflammatory. They kick on a lot of, they can kick on oncogenes and enhance cancer cell proliferation and the metastatic process. These spikes can. So the ketogenic diet and carbohydrate restriction can reduce the spikes in blood glucose and blood ketone and blood insulin, but it does not have a major effect on baseline levels of blood glucose unless the calories are restricted. So kind of getting back to what you're talking about, the ketogenic diet is, I think, it's a very good strategy to make calorie restriction tolerable, because when your brain in particular is craving glucose, and say, for example, you go on a calorie-restricted diet, but it's a high carbohydrate diet, you're still getting fluctuations in blood glucose. And the brain goes through these intermittent periods of glucose deprivation. And, your brain gets very hungry. It's not a very comfortable feeling. Nutritional ketosis, which occurs with carbohydrate restriction and is further enhanced with calorie restriction, forces the physiological shift from a glucose-based metabolism to a fatty acid and ketone metabolism. And when your body is, shall we say, keto-adapted, the brain energy metabolism is more stable, your mood is more stable. It may take a few weeks to adapt physiologically to this, but nutritional ketosis can be maintained and sustained with carbohydrate restriction, and is further enhanced with calorie restriction. And I think kind of that's where you were getting at, that total calories really need to be restricted, and also protein. So protein is gluconeogenic. So there's gluconeogenic amino acids in protein. And if protein is at, say, for example, 2 or 3 grams per kilogram per day, that is probably going to feed into the gluconeogenic pathway, and it will be hard to deplete your glycogen stores, which is necessary in the liver to drive the ketogenesis in the liver. So you really need to decrease glucose availability, carbohydrates, and protein consumption to deplete liver glycogen to maintain and sustain nutritional ketosis.
Well,
and that would be an optimized, approach.
I'd like to tease out those details, because you had mentioned, just to again sort of simplify the process, you had mentioned this rate of protein consumption with 2 to 3 grams per kilogram. That is the reason you mentioned that is because that's the typical amount of protein that a person is consuming?
It's what I consumed for many years when I was, into athletics and more physically active. I'm physically active today, and my protein consumption is probably half of what it used to be, but my performance, surprisingly, is the same or higher. So suggesting that all these years that I consumed very high amounts of protein, it was kind of unnecessary, because the ketones and fatty acids are protein sparing. So if you replace the protein and the carbohydrates, but also restrict the protein and feed your body fatty acids and elevate blood ketones, this will have a protein sparing effect. We say an anti-catabolic effect, and will help you preserve lean body mass and physical performance in the face of a calorie deficit. And this is why the ketogenic diet is an effective strategy for losing weight and retaining muscle, especially if it's complemented with resistance exercise or some kind of physical activity. But we do find that, in measuring blood ketone levels in humans and in animals, that simple carbohydrate restriction isn't enough. You really need to lower the protein. The American diet is pretty high in protein. And to achieve nutritional ketosis, which is an effective strategy for weight loss, but may not be for everyone, because some people, it depends, what the question is. If you're using it for weight loss, or you're using it for, a therapeutic intervention for cancer or seizures. And in those cases, you would want a more strict, kind of like a classical ketogenic diet that involves a protein restriction and to some extent calorie restriction, especially if it's used for a cancer therapy.
Well, let me continue to refine this a bit. Where everyone here has certainly heard of Dr. Atkins, who at his time was really probably one of the most popular doctors in the world, and was, of course, responsible for promoting the ketogenic diet. And I think what you're discussing here is a revision of that, because typically the people, and there are many people who still use an Atkins approach, but when that's typically low carbohydrate, high protein, and which will not work. It will not give you the results that you're achieving. I think that is really the key crucial element here. And this protein of 2 to 3 grams per kilogram typically translates out to 100, 150, 200 grams of protein per day for some people, which is an enormous amount. And I'm somewhat intrigued with the concept of one of my mentors, Dr. Ron Rosedale, who I suspect you're familiar with also, who's advocating a much lower dose of actually a gram per kilogram, 1 gram of lean body mass. So it's even lower than that. So typically for someone like myself, it would be 50, maybe 60, 70 grams per day. And I'm wondering if you could comment on that, especially in light of this calorie restriction, because that's another important tweak. His take on it, and it has to do with, the reason he promotes this so much is this, the protein influence, and specifically some of the amino acids, like the branched chain amino acids, influence on mTOR, mammalian target of rapamycin, which is this massive pathway that seems to be, largely responsible for much of the pathology we see in cancer growth. So, and that protein actually has a stimulatory effect on this, and when you lower that, then it's more inhibited, I guess. So, I'd like to dialogue about that protein component, and then the importance of the calorie restriction, because the calorie restriction is another twist that Dr. Rosedale doesn't go into, but I believe there may be some validity to that.
Yeah, I think we need to define kind of what the question is and what the problem is that we want to address nutritionally.
Okay.
And, it's not, I tell people the ketogenic diet, it's not a one-size-fits-all. Even carbohydrate restriction, it's really not a one-size-fits-all. And I think carbohydrates can be titrated in, perhaps, individually. I mean, some people I know have a very high carbohydrate tolerance, and they can get 800 grams of carbohydrates per day, and they maintain a very lean physique. And these are exceptions to the rule. But in and maybe they would get better results with carbohydrate restriction. But I haven't been able to convince them of that. Although they need to get frequent meals. So one advantage to eating a low carbohydrate, higher fat diet is that I can eat 2 meals a day and be totally fine. Whereas, several people I know, including my girlfriend actually, I mean, she needs to eat like every 2 or 3 hours because she has dips in blood glucose levels. And it's interesting. And my lifestyle, and I think most people can kind of put themselves into this category, would favor an eating pattern that is not so frequent. And so getting back to your original question, it depends on what you're using. If you're using it for health management and weight loss, and shall we just put it under the blanket of metabolic health, optimal metabolic health would be achieved with carbohydrate restriction, definitely, but with some level of calorie restriction, either intermittent calorie restriction or some level of calorie restriction to promote a calorie deficit, at least at certain periods of time. And if there is a period of calorie surplus, it should be kind of given in and around exercise, during or immediately after exercise. So we run into, the situation that I think it can all, and Tom Seifert would probably agree with this, that the benefits are of nutrition are achieved when you can sustain a calorie deficit. So, we're all familiar with the benefits of calorie restriction. So from my perspective, kind of like a simple perspective, it's like, how do we achieve the benefits of calorie restriction? How do we maintain low insulin and low glucose levels?